Hi everyone, welcome to MOS. So in today's video, we are taking one question which is based on the 5 transistor OTA structure. In this question, you can see one circuit is drawn here. Input is being applied at the NMOS differential pair. Input is common mode input which is denoted as VCM, whereas the load is current mirror which is being formed with the help of PMOS, and one bias current tail current source is given there which is biased using a current mirror circuit. Now in this question, it has asked to find out the range of this common mode voltage for which this op-amp can work properly. So first of all, it is very important to understand what is the meaning of this question, why we need to find this range of VCM. So we know for any such kind of structure, if we have to calculate the gain of this op-amp, let's say we are taking a single-ended output from this end, which is denoted as V out, and if I have to write the gain expression, so in general we write GM, transconductance of this input MOS, let's say 3, GM3, which would be get multiplied with R0, which will be the resistance seen from this node at the downwards and resistance seen from this node to upwards, parallel combination of that. So we can write it as R03 parallel to R02. Right, this is the gain which we will get here in the structure. Now we know if we have to get a good gain from the circuit, it is important to operate this op-amp in saturation mode of operation, because as soon as if we, let's say, apply a very small voltage at the gate of this differential pair, so what will happen, because of the low voltage, this MOS will be going into the triode region, right? So because of that, what will happen, instead of being in saturation mode of operation, it will start working in linear mode of operation, and there it will behave as a linear resistor or as a variable resistance, and that will impact the performance or the gain parameter of this op-amp, because the maximum resistance which we can get from this circuit is when it will operate in saturation mode. If it start operating in linear, we'll start seeing the drop in the performance or in drop in the gain. That's what is not desirable. So that is why it's important to find out the specific range of voltage for which all the MOSFETs can work in saturation mode of operation, so that high gain can be taken from this op-amp. So this is the significance of this question. That is why the range of VCM is asked. Now let's start calculating. So when it is asking the range of VCM, that means there would be two values we'll get. One would be VCM min and one would be max. So minimum value we will get from this path, right? And maximum we will get from upper side path. So let's start calculating the minimum one. So we know if we have to calculate the VCM minimum, so we can calculate in such a way, this tail current source has to be operate in saturation mode, and the minimum margin it could have would be equal to gate overdrive VOV, which is also denoted as VDS SAT, which would be equal to VGS of this MOS, which is denoted as VGS5 minus VT. So let's denote this as VOV, voltage overdrive. So this is the bare minimum voltage required across this MOS to keep this in saturation, and the similar would be needed for this also, right? But if we have to calculate the gate potential for this M4, so this voltage VGS can be written as delta VOV plus VT. Delta VOV of this MOS M4 plus VT, right? That's what we have seen from here. VGS we have to calculate. So we can write, this term is basically delta VOV VDS SAT. So VGS can be written as delta VOV plus VT. So delta VOV of this MOS M4 plus VT would be the minimum VGS required for this MOS. Along with that, we also need to add VOV of this MOS, right? So minimum would be needed is equal to the minimum common mode voltage which this op-amp can support would be equal to gate overdrive voltage of this MOS M4 plus VT and plus gate overdrive of this MOS M5. So that would be written as VOV of MOS M4 plus VOV of MOS M5 plus VT. This is the minimum common mode voltage which this MOS can support. I will also explain through numerical values how this will have some meaning when you actually design some op-amp. So once we will complete the answer to this question, I will tell in terms of numerical values also why this is important. Now let's talk about the maximum of VCM max, maximum of common mode voltage which this op-amp can support. So if I talk about, as I mentioned, the maximum will be explained by the upper part. So if we talk about the maximum value which this node can have would be equal to VDD minus VOB of MOS M2, right? Because VOB is the minimum voltage which is required for MOS M2 to be in saturation. And if I subtract that margin from VDD, so that's the maximum potential I can get at this node, correct? Now, if I talk about this particular net voltage, so that would be equal to how much? Let's calculate this. So just now we have understood this potential can be written as VOV of MOS M3 plus VT, right? This is the VGS value of this MOS M3. Now I need to calculate this potential, drain potential. Once we will have this drain potential value based on this calculation, I can equate this value with this value because these two nodes are sorted and we can get the maximum value of this VCM max. So as I mentioned, this gate source potential can be equal to gate overdrive of this MOS M3 plus VT. So if this MOS has to operate in saturation mode, the bare minimum condition is VDS should be equal to VGS minus VT, right? I can write it as VD minus VS should be equal to VZ minus VS minus VT. Now VS will get cancelled out. VD we need to find out this potential, right? Because this we need to equate with this. Gate voltage is nothing but the input VCM max which we are trying to find out right now, and VT is VT. So if I equate this value with this VDD minus overdrive of this MOS M2, I can find out the VCM max, right? So let's equate this here. VCM max minus VT should be equal to VDD minus V over gate overdrive voltage of MOSFET 2. So VCM max, if I have to calculate from here, it would be equal to VDD plus VT minus gate overdrive of MOS M2. So that's the answer of this question where it was asked to find out the range of VCM. So we have calculated VCM min also and we have calculated VCM max also. Now just to explain the significance of this value, why it is very important in analog design, because let's consider the threshold voltage of MOS is 600 millivolt. Gate overdrive for all the MOSFET, let's calculate as 0.2 volt, 200 millivolt. So you will see VCM minimum is 1 volt, and if I talk about VCM max, so VDD let's calculate as, consider as 2 volt. So 2 plus VT is we have taken as 0.6 and gate overdrive we have taken 0.2, so 2.4. So basically your input can switch from 1 volt to 2.4 volt. For this range of voltage, your amplifier will work perfectly. If your voltage drops below 1 volt, your MOSFET, your op-amp will start having a bad performance because its gain will start decreasing because one MOS will go into linear mode of reason. Similarly, if its maximum potential goes beyond 2.4, again the same thing will happen. So this is why it's very important to understand for what range of input your op-amp can work perfectly. And this is also one challenge if you have to reduce, let's say you need to support for 0.6 volt of input, where input is toggling from 0.6 to 3 volt, then how you will design your op-amp. That's a different thing which we will study at this channel later on in next videos. But that's the significance of this two parameters which we have calculated. So I hope you might have learned something new from this video. If you found this video useful, please share with your friends. And if you haven't subscribed this channel, please do subscribe. Thank you so much for watching this.